So this is an organic chemistry demonstration, and you guys have been learning about kind of the different structures and uses of different organic molecules. So today we're going to be looking at two alcohols, methanol and ethanol, and seeing how they react with iodine and sodium hydroxide solution. So in this beaker here we have methanol, which if you'll remember is a one carbon molecule with an alcohol group on the side. And in this tube right here we have ethanol, so it's the same thing but two carbons and then the alcohol group. So I'll just put these right here kind of as our labels. So next we're going to add 25 drops of the iodine solution to each tube. And then we're going to add 10 drops of sodium hydroxide to each tube. And then as I swirl them, you'll be able to see the color change. So as you can see, not much is happening with the methanol one, but the ethanol one is forming a yellow precipitate. Okay, so let's take a look at what happened. We said the methanol basically didn't react. This is the structure of methanol. And then we said the ethanol, what was happening is it's actually forming what's called triiodomethane. So when you guys talked about naming in class, that just means that it's a methane group, so one carbon with three iodide atoms surrounding it, and then it also formed the formate anion. So there's our structure of ethanol, then that's the structure of triiodomethane and the formate anion, and the triiodomethane is actually a yellow solid. So that is what we saw as our precipitate that formed. Okay, so let's take a look at a visual representation of what we just said. So remember, we started with ethanol, which is this molecule over here, and we reacted it and got iodoform and the formate ion. So we said that this yellow precipitate in the bottom is the iodoform, or triiodomethane is the IUPAC name. So that means that there's one carbon in the middle, three iodines around it, and then that's the hydrogen on the top. And remember, this is tetrahedral geometry. And then we also said that we formed the formate anion, which is this molecule right here. So it's one carbon, two oxygens, and one of them is a double bond, and then a hydrogen over here. So as an anion, this is actually an ester because it's a double bonded oxygen and then a single bonded oxygen. But if we were to add on the hydrogen back to it, so get rid of that negative charge, then it would become formic acid, which is a carboxylic acid. Okay, so the reason why the ethanol reacted to produce these two things, but the methanol didn't react, is that ethanol is actually the only primary alcohol that can undergo this reaction. So these are both primary alcohols because this carbon is bonded to, this hydroxide group is bonded to one other carbon. Same thing here, this hydroxide group is bonded to one other carbon. So they're both primary alcohols, but like we said, ethanol is the only one that can undergo this reaction. And the reason for that is beyond the scope of Chemistry 101, but basically when you get into organic chemistry and start talking about reaction mechanisms and stuff like that, what happens is the ethanol undergoes a three-part mechanism that the first step is oxidation, which you guys have talked about. The second step is substitution. And then the third step is hydrolysis, which you guys have talked about. But just another way to kind of think about it for the scope of this class is the ethanol has two carbons and our final products need two carbons. So that's just a basic reason of why the methanol doesn't react.